Okay, so today I wanted to talk about the difference between um, a variety, or just define like what a variety is, and a manifold. Okay, so a manifold, it's a space that looks locally like Rn, so an n-dimensional manifold. Actually, put Rn like here. N-dimensional manifold looks like Rn locally, but globally probably has some curvature. Does not need to look like Rn, basically, right? Okay, a variety is largely similar. Okay, you can think of it as just some kind of hypersurface. Um, However, there is two major differences. So, two major differences. One is that it has some singularities, and two, it is described by a polynomial globally. Okay, so one is that does looks like Rn, pretty much like almost um, yeah, it looks like Rn like almost everywhere, but has uh, corners, pinches, cusps, crossings, or X's as they call them. And two, the entire thing is the entire, well, um, classically, the entire object, the entire thing is described by a polynomial. Specifically, it is a polynomial set equal to 0. So we call it the 0 set of a polynomial. So for example, if I have a graph, this thing is clearly a manifold, okay? It is a manifold. It is very similar locally to R1, okay? Very similar to R1. However, this is a, I think this, yeah, this is a variety. Yeah, okay. This locally right here, this crossing does not look like, yeah, it does not look like R1. For a manifold, you can zoom in at any point, and if you zoom in enough, every single patch along the manifold will look like R1. Here, no matter how much you zoom in, it will not look like R1. And this is described by, let me see if I get this right. One moment, I believe is y is equal to x plus 1. Yes, this is something like y squared is equal to x squared x plus 1. Yeah, and if you move everything to one side, what would you get? You would get, let me just type it out really quickly, y squared minus x to the third minus x squared is equal to 0. Yeah, so if you have a function of many different variables, and then all of them were to some power, and you moved everything to one side, and you set it equal to 0, yeah, that would yeah, that would be a variety, the 0 set of a polynomial. When you set a polynomial equal to 0 and you graph it, that is a variety. And very similar to manifolds, except that manifolds, you cannot have what we call singularities. This is also another one, a variety. A manifold cannot have this corner, but a variety can. You zoom in, you cannot get rid of this. Yeah, the difference between a variety and a manifold. To add on top of that, a manifold, okay, several patches of the manifold can be described, uh, locally by polynomials. And if you manage to glue them together, then you have a manifold that's described by a couple of different polynomials. A variety, the classical ones that we usually study, or were studied first, it is one single global polynomial, okay? One single polynomial that describes the entire variety globally everywhere, okay? And nowadays there are people have been piecing polynomials together. Now you probably noticed that okay, if I just had one variable, so like x to the any degree plus x to the n minus 1 all the way down to x to the 0 with any kind of coefficients like a, b, c, so on and so forth. Actually, these are just like discrete sets of points. Technically, I mean, I wouldn't not say a variety, but not much of a smooth kind of a surface or hypersurface. So often we do need at least two variables, x and y, in order to get something smooth, something that you can like touch and plot. What we kind of imagine to be surfaces. But yeah, manifolds not described globally by polynomials very often. Sometimes you can glue polynomials or functions together, but varieties, often one polynomial to globally describe the entire variety, okay? And then discrete points for one variable, and then above one variable, now you're getting surfaces, hypersurfaces.